Okay, so welcome back to another Math 9 video. We're doing 6.2, which is removing fractions, decimals, and brackets. So if we have an equation that is like this, we want to get rid of our fractions here. So the first thing that we would do is that we would take a look at all of our denominators that are in here. So the 4, the 3, and the 6. And we want to find a common denominator or least common multiple. They both mean the same thing. But we want a number that 4, 3, and 6 all go into. So I would say the best choice in our situation would be to pick the number 12. And then what we want to do is distribute that 12 to this term. So we'll start with this one first. I know there's a lot going on, so take it step by step. And here I would look at this and say, okay, 12 times 1 is 12 divided by 4 is 3. So I'd be left with 3x. Another way you could look at that is you could say 4 goes into 12 3 times, and that's how I end up with this 3 down here. So take your pick of what you find easiest. And then we want to move on to our next term here and distribute the 12 over to this term. So 12 times 1 over 3, again, we could look at it and say how many times does 3 go into 12? And we know that it's 4 times. So I'd get a minus 4 because this sign that's here, the sign that's to the left of the term stays with that term. So maybe it would have been better if I extended this line all the way over there to include it. And then I take my 12 and now I distribute it over the equal sign. So we have that this is equal to over to this term over here, that's 1 over 6x. So again, I would say 6 goes into 12 2 times, so I would end up with 2x after distributing that. So you can take a look at this and compare and contrast. The initial equation that's written in white is much easier to work with down here when we've wiped out all the fractions. So a lot of people find fractions and decimals to be confusing. No problem. We wipe them out right in the first step, and that makes it much easier for us to work with this. So at this point, I have some options for where I could go with this. I could move I want to get the like terms together, so I want these two to be together. I could move the 3x over. Or I could move the 2x over to the left. It doesn't really matter, so let's get rid of the 3x by doing minus 3x on both sides. So on the left, I would just have a minus 4 left, because 3x minus 3x is simply 0. And on the right side, I'd have 2x minus 3x is negative x. And we don't want a negative x, so our way of getting rid of a negative is we could divide both sides by negative 1. The other option is I could multiply both sides by negative 1, and I'm going to accomplish the same thing. But our whole reason for doing that is because a negative and a negative cancels out to give us a positive x. A negative 4 over negative 1 also gives us a positive, so it's positive 4. And just as a habit, I like to reverse these, which we are allowed to do, because I didn't actually change the answer at all. But after all that work, we can say that our answer simplifies to x equals 4. So you can see the whole step-by-step process that's listed there. So that's how we get rid of fractions. But sometimes we have fractions that have a little bit more going on. So in this one, I guess the biggest difference is if we take a look at the top here, we have 2 terms in the numerator of that first fraction. But we still can take the same approach. So we want to look at this 3, 2, and 6 and find something that they all have in common. So the least common multiple or the lowest common denominator. So in this case, we want to multiply the whole thing by 6. Just to make this easier to work with, I'm going to get rid of that. And we want to do the same thing as last time where we distribute this by multiplying it by the first term. But let me show you a trick that's going to make this much easier to work with. I could do 6 times 2x and then 6 times 5 and then the whole thing's going to be over 3, but that's a lot of work to do. An easier way to do this is to look at this and say, okay, how many times does 3 go into 6? And the answer would be twice. So I'd be left with a 2 outside with a 2x plus 5 on the inside still. So I'm going to get rid of that line because I wanted to do that for the first term. That helps me to take care of this one. But now I have to go back and deal with my second term by distributing the 6 over the equal sign. So I'm doing 6 times a half. Again, I can look at this and say, how many times does 2 go into 6? The answer is 3 times, so I get a 3 there. It's the same thing as doing 6 times 1 divided by 2. But looking at it that other way of how many times does 2 go into 6 makes it sometimes a little bit easier to work with. And then we go back to the 6 and distribute it to our last term. Notice there's a plus sign in front of it, so I know I'm going to have a plus here. And if I have a 6 that I'm multiplying by, so that one there, and a 6 at the bottom, we know that the 2 of those are going to cancel, so it just leaves me with a plus x there. So you can see that it still has a lot of stuff going on, but it's starting to look a little bit easier because we've eliminated and gotten rid of all the fractions that were at the bottom. So let me zoom in on this and show you, even this has a lot going on, but to make it a little bit easier, we can just ignore everything to the right of the equal sign. So for a minute, we're just going to zoom in on the left side of the equation. If I just gave you something like this, we know that we would distribute the 2 to get a 4x right there, and then I'd go back and distribute it here. So I would get a 4x plus 10 just on the left side of the equal sign. And then the rest of this is still looking the same. That's going to be equal to 3 plus x. And now you can see we got rid of the fractions in the first step. That's the part I've eliminated here. Second step, we got rid of the brackets by distributing that too. And now, zooming in on this equation, we want to collect our like terms together. So I have a couple of options here. I could move my 4x to the right side of the equal sign, or I could move my x to the left side of the equal sign. It doesn't really matter, but I think that it's often better to choose the smaller value to move so that we can keep the answer positive, or we can keep the x's positive. So I'm going to say let's subtract x on both sides of the equal sign. That leaves me with a plus 3 on the right, but x minus x would just cancel. And on the left, 4x minus x is going to give us 3x, and I still have the plus 10 afterwards. And then our next step from here is we want to get our like terms together. So we want to get these two together. So I can subtract 10 on both sides. So I would get 10 minus 10 is just gone, so I just have a 3x left there. And 3 minus 10 is going to be minus 7. And then we want x by itself, so we would divide both sides by 3. We've been doing this for a while. Remember, algebra is all about opposites, so if you're multiplying 3 times x, the opposite would be dividing by 3. So we do that to get rid of these, and we would get x equals negative 7 over 3. Now, I could leave it like this, but notice that this is an improper fraction. So I'm going to say or, I'm going to move the negative sign off to the side, and I'm going to say, okay, how many times does 3 go into 7? And it goes in 2 times, because 3 times 2 is 6. The denominator stays the same, so the 3 that's down here stays there. And if 3 goes into there twice, I'd get 6, which 7 minus 6 is just 1. So I'd get negative 2 1/3, which is the same thing as this. So either one would be fine, but it's better to leave it as a mixed number instead of an improper fraction. So leaving it in that form is a good way to put it. And then moving on to dealing with decimals. So we take a look at this equation, and we notice that there's a whole bunch of decimals. So similar to the fraction situation, we want to wipe out the decimals. So we take a look at this, and I notice that to get rid of the decimals, I'd have to move this over 3 times. Here I need to move it over twice, and here I need to move it over 1, 2, 3 times. Here it would be twice. So I choose the largest one, and I use that to decide what I'm going to multiply this by. So I want to multiply the whole thing by 1,000. And I chose 1,000 because of the fact that I needed to move the decimal over 3 times, which is why I need 3 zeros there in order to get rid of it. Okay, so now we go through just like we did with the fractions and we start distributing this. If I multiply 0.002x by 1,000, well, we just move this over 1, 2, 3 times, so I would actually get 2x. Then I want to do the same thing with the next term. I go back to 1,000 and I distribute it here. If I'm multiplying this by 1,000, I'd go 1, 2, 3, so I'd actually get plus 50 equals, and then I want to go back and multiply 1,000 by this. So I'd go 1, 2, 3, so I'd have 30x. And then on to my last one, I'd go back to the 1,000 and I'd distribute it here. So I would have minus 6. So you can see that this colorful equation here is much easier to work with than all the decimals and the terms that we had up above. So looking at this here, we want to get our like terms together. So we want these two together and we want these two together. That didn't help. Let's do this, these two together. So maybe a good way to do that is to subtract 2x on both sides, which would get rid of it here. So we would have 50 equals 30x minus 2x would give us 28x minus 6. So we have this going on. We want to, again, get our like terms together. So I want to add 6 here, which means I have to add 6 here, which gets rid of it. So we would have 28x, because this minus 6 plus 6 is gone, and 50 plus 6 would give us 56. Our goal is to get x by itself, so we're going to divide both sides by 28, because again, remember, algebra is all about opposites, so that would cancel. And so we would be left with x equals 56 over 28, which is 2. And again, it doesn't really matter, but I just like to get into this habit of writing it with the variable on the left side and the solution on the right side. So I hope you found that helpful. Your assignment is numbers 1 to 4, just the odd letters, so A, C, E, etc.